All right, so let's see if we can finish our test here. So it says 19 says determine if it converges or diverges. And the only thing that we need to look at here is what is the value of the common ratio. Because the rule is this: if the absolute value of the common ratio is less than 1, it's going to converge. If it's greater than 1, it's going to diverge. Because if it's less than 1, that means the terms are going to get smaller and smaller as you go out to infinity. So this dot 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 here means that it's an infinite series. So how can we find the common ratio when it's kind of a little bit complicated with these fractions? You can basically take a term and divide it by the term right before. So 27 over 4 divided by 81 over 8, dividing by a fraction is the same as multiplying by the reciprocal, which is 8 over 81. Okay, then if you look at this, 4 goes into itself once, it goes into that twice. 27 goes into itself once, and it goes into that 3 times. So we're left with 2 over 3. Okay, and you could obviously test the other one too. You could do this divided by this. You'll still get 2 over 3. So in either case, r is less than 1. The absolute value is less than 1, so that means it's going to converge. All right, number 20 says evaluate the infinite series. Here's our formula right here. All we have to do is plug this in. So S sub n is equal to our first term 1 over 1, 1 times, 1 over 1 minus r. Now we don't know what r is, but we can find it using the same thing that we just did. So we'll take negative 0.6 and divide it by 1. And of course we get negative 0.6, or you could do this divided by this. You'll still get negative 0.6. This is the same as 6/10, and that's the same as 3/5 or negative 3/5. And it's usually a little bit easier, especially if you're doing these by hand. It tends to be easier to do these with fractions rather than with decimals. At least I prefer to do it that way. You may prefer to do different. So we'll do equals. We don't really need this 1 here because 1 times anything is just the same thing, so we'll get rid of it. And then we have 1 minus r, and r is that. R is negative 3/5. So minus negative 3/5 is like plus 3/5. And by the way, 1 as a fraction is like 5 over 5. And the reason we change it to that is because it needs to have a common denominator with 3 over 5. So 5 over 5 plus 3 over 5 would be 8 over 5. And then dividing by 8 over 5 is like multiplying by 5 over 8. So 1 times 5 over 8 just equals 5 over 8. And that's the sum of that infinite series right there. 21 is the same type of thing. We just have to kind of expand this out. So let's get actually we only need the first term. We can find the first term by plugging in this number, and obviously we can't plug in the last term. There is no last term because it's infinite series. So we'll plug in 1 right here. So we have negative 768, and then 1 is getting plugged in there, so we have times 1/4 to the 0. Anything to the 0 is 1. So negative 768 times 1 is just negative 768. So our formula is going to be this. It's going to be the first term, and we're using, again, this one right here, and then times 1 over 1 minus r, which is that. R is the number that you're raising to the power. So 1 minus 1/4. And then from there, all we have to do is to simplify this. So we have negative 768 times 1 over 1 minus 1/4 is 3/4. And then again, dividing by 3/4 is like multiplying by 4/3. So that this thing in parentheses just becomes 4/3. Then we should be able to cancel. So 3 goes into itself once, and 3 goes into that negative 256 times, because there's a negative right there. Negative 256 times 4 is negative 1024, and that's the sum of that infinite series in sigma notation. 22 is we're going to use the same formula. This time they are giving us the sum, and we are asked to find the r value. So let's plug that in. So the sum right here is negative 5.25, and our a sub 1 is this number right here, negative 8.4, and then we have 1 over 1 minus r. Let's multiply this right here. We'll get it to look like a proportion when we do that. So we'll have negative 8.4 over 1 minus r, and this as a fraction, if you wanted to write as a fraction, it would be over 1. And now we can do what you probably have learned how to do in geometry, which is cross multiply. So 1 times negative 8.4 is negative 8.4. This number times both of these, because we have to distribute to both, would be negative 5.25. And then the negative times that negative will be a positive 5.25r. Okay, now what we need to do is add this to both sides. Now it's just a regular algebra equation that we're familiar with solving. And what do we get when we do this? This goes away. We get 5.25r, and that is going to be equal to negative 3.15 is what the other side comes out to be. And then at this point, we can, if we had done this using fractions, it would probably be easier to do it by hand, but you may as well just use a calculator for that. So we have to divide both sides by 5.25, and this will give us the r value. And it should be, the absolute value of this should be less than 1. We already said that because if it wasn't less than 1, obviously it would not be a converging series. We wouldn't even be able to find the sum. And when you do this, it turns out to be negative 0.6, or if you prefer as a fraction, negative 3/5 would be our result. That's and that of course it does have an absolute value less than 1, so that makes sense. All right, 10 points, or this next section right here, these are just labels to help us keep track. So this is the section on binomial expansion, and this one is going, because we're raising to the third power, we'll have 4 terms, and the pattern goes like this. It goes 3 choose 0, and then it's going to be 3 choose 1. We're leaving these blank for now so we can fill them in later. And then we're going to have 3 choose 2, and then finally we'll have 3 choose 3. Okay, then what goes in here, it's going to be the first term, x to the third, and then to the second, and then to the first, and the last one to the 0, but that just equals 1, so we'll cross it off. Then we have our second term, 5 to the 0, which again is 1, so we don't need it. 5 to the first, 5 to the second, and finally 5 to the third. Now all we have to do is expand this out. 3 choose 0 is 1, and so is this, and you could put those in a calculator. That number is 3, and that number is also 3. So the first term is just going to be 1 times x cubed, which is x cubed. Then we have 3 times 5 is 15, and then we still have this x squared right there. Okay, then we have 3 times 5 squared. 5 squared is 25, so 3 times 25 is 75, times that x will be 75x. Lastly, we have 1 times, there are no x's, and 5 to the third is 125. So our final expanded answer is that right there. The next one is slightly more involved. It's going to be the same type of thing, but we do have more terms this time, and we also have, let's leave a lot of space here, we also have exponents in here as well. So we're going to have 5 terms. So our first term will be 4 choose 0, and then we're going to have something with 4 choose 1, and then 4 choose 2, and then the last 2 of course will be 4 choose 3 and 4 choose 4. Okay, so let's just evaluate, well, we'll evaluate those numbers second. Next thing is our first term is y to the fourth, and that's going to start out being raised to the fourth, then to the third, then to the second, and so on, following that pattern. So the first, the last one is to the 0, but again that equals 1, so we don't need it. All right, the next thing is, and I'm going to change that to plus negative 2x. We have negative 2x to the 0, which is 1, negative 2x to the first, then negative 2x to the second, negative 2x to the third, and negative 2x to the fourth. Now all we have to do is simplify. This number equals 1, and so does this. This number equals 4, and so does that. And this number equals 6. So our first term is 1 times that. Y to the fourth is going to be y to the 16. Okay, then because of this negative right here, the signs are going to alternate. So this is going to be a minus. Negative 2x times 4 is negative 8x times this thing right here. That 4 times 3 will be to the 12th. So this is going to be minus 8x. Actually, let's put the y. It doesn't matter what order you put them, but just to stay consistent, we're putting the y's first. So that way you can kind of see the pattern a little bit better. So the next one is going to be 8 y to the 12th x. Next one will be positive. We're going to have 6 times negative 2x squared. Negative 2 times negative 2 is 4, and x to the second is just x to the second. So 6 times this 4 will be 24. The y is going to be 4 times 2 is 8, and then that x is just x squared. Next one following our pattern should be negative. We have 4 times y to the fourth, and then this thing, negative 2 to the third is negative 8, and x to the third is just x to the third. So 4 times negative 8 is negative 32. This term, 4 times 1, for those exponents on the y, will be y to the fourth, and then we say we have x cubed. All right, so actually let me just double check that we are following the pattern correctly. It seems like we are. All right, and then And then our last term is going to be 1 times this. Negative 2 to the fourth is 16, and x to the fourth is just x to the fourth. So our last term is just going to be 16 x to the fourth, and there is our 5-term expansion. All right, the last 3 are on combinations and permutations. So the first one is just asking us to find the number of outcomes in given scenarios. So it says a new car is available in sedan or hatchback. So we have 2 choices for the model type. And then we have to multiply that by 1, 2, 3, 4 choices for the color. So 2 times 4, and that is just going to equal 8. So there are 8 possible outcomes. You could kind of draw a picture. You could say, well, I take sedan or hatchback, and then sedan could have red, it could have white, it could have green, it could have black, and the same down here, and you'd be able to see visually that it's 8. Okay, 26 is a little bit more complicated. It says 5 rooms need to be painted, so we have to make a decision on each of the 5 rooms. And the wrong way to do this, by the way, is to just say 5 rooms times 3 colors, because it's not 15, and I'll show you why in just a sec. On room 1, we have 3 choices. I could paint white, yellow, or pink. Times. On room 2, I have 3 choices. On room 3, I have 3 choices. I have 3 there, and I have 3 there. This is the same as 3 to the 5th power. This is the number of choices you're making, by the way. We're making 5 choices. And this is how many options per choice. We have 3 colors. And so 3 to the 5th power, this turns out to be 243. Now you might ask, why is it not just 3 times 5? That would be a lot simpler, and that's true. But simple doesn't always mean right. So I'll show you a picture. Let's suppose we are painting room 1. And we could do white, we could do yellow, or we could do pink. Okay, now we've painted room 1, now we're going to room 2. So suppose we started out painting white. Well, we could do white for room 2, or we could do yellow for room 2, or we could do pink. We could do the same here. We could have gone yellow on room 1, and then white, or yellow, or pink. And the same here. We could have done white, yellow, or pink. So notice we're only on room 2, and we already have, if you count those up, we have 3 on each of these. We have, oops, let me move it just a little bit so you can see it. We already have 9 choices. We have 3 right here, 3 right here. So we're at 9. We're only on room 2. Let's see what happens on room 3. So suppose we went white, white, and then we could go white on the 3rd, or yellow, or pink. Or we could have gone white, yellow, and then that will result in white, yellow, or pink. And then the same thing here. We could go white. So you can see already we're only on room 3, and we already have 9 on this one. We're going to have another 9 right here, and another 9 right here. So we're at 27 options, and we still have 2 more to go. So every time you do this, you're multiplying by 3, and that's where we get 3 times 3 times 3. That's where we get the number 243 from. All right, last problem. It says decide if it's permutations or combinations and find the numbers. So 45 people running a race. The top 3 earn gold, silver, and bronze. So suppose Albert, Bernard, and Charles are running this race. Or suppose that they finish this way, Charles, Bernard, and Albert. And the question is there any difference here? And the answer is yes, there is, because in this scenario, Albert is happy. He won the gold. In this scenario, he's not as happy as Charles, because Charles won the gold. So the order matters. When the order or position matters, remember the word position starts with a P. That's how I remember it. That means we're dealing with a permutation. So the question is, we're going to have how many people, and we're picking how many. We have 45 people, and we are picking 3 runners. We're picking 3. So there's 45 people that could finish in first. There's 44 that could finish in second. There's 43. This is what your calculator is going to do when you plug that in right there. And you certainly would want to use a calculator for these. For a lot of these problems, they're pretty big numbers. This one is pretty big. It's 85,140 possible ways that those 45 runners could finish.